All right. So can you guys see my screen now?
Yes, sir.
Yes, sir.
Yes, sir.
So wait a second. All right, there you go. So still have a lot of tabs, so forgot to close them. Anyway, so anyone, let's start with the with your questions or queries if ever there is. Anyone who has a question regarding with the midterms from week one to the midterm exam? Anyone? Or does anyone who has a question regarding with your midterm exam? All right. So
Wala naman po, sir.
none. So we can start now with our finals. It's week 7 and 8, which is the software design. Okay, so let's go over to the overview of this week 7 and 8. So in here you will see that we only have two topic learning outcomes, but then again we have here the the list of topics that we're going to discuss under this module. So in here we're going to design, implement, evaluate the computer-based system, process, component, or program to meet desired needs. Okay, we'll also use current techniques, skills, and tools necessary for computing software design. Okay, and then here are the lists that we will discuss under this module. So first one is the design concept. Second is objectives of software design. Third is the software design principles, wherein we have four different types of principles. We have the problem partitioning, modularity, instruction, and strategy. And then we also have coupling and cohesion, function-oriented design, object-oriented design, and then user interface design. So we have two PDF under this module. We have software design itself, which is the one that we're going to discuss later on. And then we have the cohesion and coupling. So I believe that Mom Teresa just added this one because this one came from her class OOP, object-oriented programming. So this is just an additional information or additional concept regarding what with what is a cohesion and then coupling. Okay, so just to clarify, we will not discuss this one anymore since this is just a supplement. Okay, what we're going to discuss for today is software design only. Okay, so in here I cannot actually find you know uh, a super matching video with those given topics. So I just decided to get a long video, which is a 1 hour and 40 minute video, which talks about the system design course. Okay, or this one is actually quite similar with the software design. Okay, so that is why I just added this one. So this is an hour and 40 minute video. Okay, so just check this one out later on if ever you need more information regarding the software design. Okay, so the only that I was able to find is this design concept, which is the very first one, but still it's not that super exactly related. Okay, so this one is like more in a general explanation. Okay, so this one is actually wide. Wherein it discusses a lot of topics, not just the design concept, which one that I'm looking for, which discuss only maybe 5 to 10 minutes. Okay, so possible if we have a video wherein can discuss or explain in 3 to 5 minute video, then that is the one that I'll put in here. Okay, but anyway, so just check them out. Maybe you can still get some useful information. Okay, and then we have two reading materials. So this one came again from Kaufman and Wolfgang, and then the other one came from Nagalaxmi Talkar. So just check them out. So the or this PDF talks about the software design itself. Okay, so this one is from the Wolfman, Kaufman and Wolfgang rather. Why is it black? I don't know what happened. Lang. Wait a second. Why is this link not working? Maybe the website itself was already gone. Anyway, I'll just replace this one later on. But for now, this is the only one that is working. Okay. So this is a 39 slides, which talks about software design or SDLC life cycle. And then the abstract and so on and so forth. Anyway. So yeah, that's it for the overview under this week 7 and 8. And then we have one or let's just say reference wherein most of the PowerPoint came from. So this one came from the tutorials one. Okay. Anyway, so are we clear so far regarding with the module overview?
Yes, sir.
Yes, sir.
Yes, sir.
So if ever that you have, again, if you have a question, so don't be shy to ask, okay? Just let me know if you have this question in your mind. All right, so I guess we can proceed now to the OER or the learning materials rather, the PDF itself of the software design, which is this one. All right, so this is the 24 slide, but what I will do is I'll just give you guys the briefing, okay, or I'll just mention the important thing, okay, or the important things under this module. So I will not read all of them one by one because of course you guys can read it on your own. Okay, it would be a lot better if you yourself is the one reading it and then trying to understand it and then try to uh, analyze everything, okay, with your own uh, intellectual. Okay? For example, if there is one sentence or one paragraph that you cannot understand, then that's maybe the time that you can ask me or message me via Canvas or Facebook. Okay, but I think most of the description, okay, except for some terminologies are quite not that clear, especially that Mom Teresa have used some highfalutin words. Okay, so while I was actually reading this PDF, so I saw a lot of highfalutin words wherein I need to Google it since I don't know the meaning of that word. So pardon me later on if we will use Google, just to ask what is the meaning of the specific word and so on and so forth. Okay, so I'm not that expert when it comes to English. Okay, well, I just know the basics, but when it comes to maybe uh, some difficult terminologies, so that is one thing that I'm not familiar with. Anyway, so let's talk about the description or the definition of software design. So it is a process by which an agent creates a specific edition of a software artifact intended to accomplish goals using a set of primitive components and subject constraints. Okay, so basically this is just a guide. Okay, or you can just simply see that this is a method or a technique. Okay, well, it actually has a lot of definitions when if you're going to search this one in Google, but we only have two most exact definition or description of the software design. Software design is actually a process, okay, or a model or a process and a model rather that you can follow, okay, to for you to be able to finish that software or that program that you're creating. Okay, so you can think of it as a process or a model. Okay, so all the activity involved is of course in conceptualizing, framing, implementing, commissioning, and ultimately modifying complex systems, or the activity following a requirements specification and before programming as stylized software engineering process. So in here, basically it involves from the start up to the very end in creating the project. Okay, from conceptualizing up to the framing, to the implementing, up to commissioning, and so on and so forth. Okay, so this one mostly involves problem solving and then planning a software solution. So we have software design because we have this problem that you want to solve in a certain sequence or pattern that is already made. Okay, so this is not like the design thinking wherein it is you who's going to come up with this one, and then it is you who's going to come up with this solution. So software design is more on a pattern. Okay, so if there is this problem, so you will use an existing solution to solve that problem. Okay, so we already have a lot of patterns, techniques, tips on how to solve that problem. So it might be a different problem, but still, this existing solution might be applicable to solve that specific problem. Okay, so again, to make it short, those description, a software design is a both a process and a model at some time. Okay. So it is important to note, however, that design process is not always a straightforward procedure. So yes, even though this one is uh, a big help when it comes to, from the very start up to the end in creating that project yours, this one is still not that straightforward. So you still need to come up with alternatives, maybe, okay, or with your own ways in solving things. So let's just say that design model can be compared to an architect's plan for a house. So we all know that an architect plans is still not 100% foolproof to finish your house. So there are some changes. There are some adjustments. There are some maybe problems that will arise in the future. So maybe the estimated amount, let's say, of your house from 2 million became 2.5 million. So that is already a problem. The estimated time to finish your house is, let's say, in 2 years became 3 years. So that is another problem. So yes, it is not that straightforward if you're going to follow that process or pattern that that architect or that person or that programmer created. Okay, so we still have to think of alternatives or probably another solution to solve that specific problem. Okay. Anyway, it begins by representing the totality of the thing that is to build. Of course, let's say three-dimensional rendering of the house, and then slowly the thing is refined to provide guidance for constructing each detail, like for example, planning lay. Then similarly, the design model that is created for software provides a variety of different views of the computer software. Okay, but yeah, in other words, again, this one is not that foolproof. Okay. Anyway, so we have here some basic design principles, which was came from this McGraw-Hill, okay, or this person McGraw-Hill at the year 1995. So this is already a concept created way back 1990s. So I do believe that this one's still useful up to date, okay, even though it's already 27 years have already passed. This is still applicable. Okay, so the first principle that came from Mr. Wait a minute, who is this Stevie? Stevie is E20 McGraw-Hill. So I don't really know who is the author or who's the one who come up with this principle, but I think it's Davis and then McGraw-Hill. Okay. Anyway, let's just say that it's the two of them, maybe. But yeah, this one came from this person, and let's just say that this person also. Anyway, first one is the design process should not suffer from tunnel vision. I guess this one's very straightforward. When you say tunnel vision, if you only have this plan, then you don't consider other alternatives anymore. So you must not restrict your plan in this kind of uh, process or this tunnel vision that they're calling. Okay, so if you can find, while creating or while doing your project, if you can find a better alternative in finishing your project way better, way faster, then why not to adapt that one? Okay, it won't harm you, but instead will help you to finish your project as early as possible and then as better as possible. Okay, so do not uh, only focus on your creative plan. Okay. Second one is design should be traceable to the analysis model. Okay, because a single element of design model can be often traced back to multiple requirements. It is necessary to have means for tracking how requirements have been satisfied by the design model. Okay, so in other words, you must have a uh, well documentation or a well guideline, or let's say, how do you call this one? Uh, let's say a well flow of program. Okay, in while you're creating your project. So in other words, it should not be hard to follow if someone will try to uh, say redo or revise your project. Okay, so it should be traceable to the analysis model. Third one is the design should not reinvent the wheel. Well, if it's already there, then of course there's no need to reinvent that one. Well, we can come up with alternative way or a different way in doing that one, but still you arrive with the same uh, solution, or we arrive with the same system. So this one should be, or our time should be invested in truly new ideas. Okay, not in an existing idea, and you just propose another way in doing that. Well, that's good that you have proposed another ways on alternative way in doing that one, but still it is already solved by this kind of method or a program. Okay, so as much as possible, try to come up with a new problem and then new solution. Okay, with that, we'll be able to save our time. Okay, and then the next one here is the design should minimize the intellectual distance between software and then the problem as it exists in the real world. Okay, now the best thing for me to describe this one is by using this drawing. Let's say this is the problem, and then this is the solution. Okay. So let's say we have this problem and then we have this solution. So as much as possible, it should be, very specific, where in this problem we'll be able to solve by this solution. Okay. Wherein this one is the correct one. Okay. Very straightforward. Okay. The distance, the intellectual distance between the software and then the problem is not that far. In other words, it's very straightforward. Now, if you have this problem, and then you have this solution, this solution, this solution, and then you have another, uh, separate ways or dissected part in doing that one. Like you have three parts before you can finish its problem. Well, I think this is not a good idea. Okay. Well, still okay, but as much as possible, make it as simple as possible. Wherein you can, if you can come up with one sentence or with uh, from straight to the point in solving that problem, then that is the perfect way in solving the problem. Okay, of course, the lesser the solution, the better. I think that is uh, the best way to think of it. The lesser the solution to solve the problem, the better. Okay, of course, the longer the solution or the more the solution, the more complex it is. So it's now more difficult to solve that problem. So in other words, we have to work, or we have to think wisely, uh, uh, doing or in creating our solution with that specific problem. Okay, so are we clear so far? Were you guys able to follow what I mean by this minimizing the intellectual distance. Hello, hello. You
Yes,
guys
sir.
still around?
Yes.
I hope you
Yes,
guys can
sir.
still follow.
Yes, sir.
Anyway, thank you, thank you. Okay. Anyway, the next one is the design should exhibit uniformity and integration. Okay, as much as possible, I think the word uniformity is already clear, and then as much as possible, you must use integration in all of your projects. So instead of writing everything from scratch, why not just integrate that part, or why not just integrate that module? Okay, so in here it's just like working wisely by integrating things that is already existing. Okay, if it's already existing, then just integrate that one to your system. You don't need to recreate that one. You don't need to uh, come up with a new let's say solution. If it's already existing, then I just integrate that one. With that, it would be a lot easier for you to finish your project. Okay. And the next one, the design should be structured to accommodate change. Okay. So I think this one is also very straightforward when it's structured. So you must have this levels, okay, of let's say problem to solution, wherein it's traceable. Okay, that's the main advantage if your way of doing things is structured. Say you have or you want to create a pizza ordering system. Okay, of course we will start with the login first, maybe, or the dashboard, okay, or the home page, so whatever you want to call that. And then in that it was divided into 3 parts. So let's say this is the this is where you can order, okay, or the customer can order. This is where they can maybe reserve. Okay, and then this part may be, I don't know, but just another feature, okay, that you can think of with this pizza ordering system. But yeah, here under order, so we have, let's see, categories maybe, and then for maybe for the food, and then for the drinks. Okay, so in here you've created this interface of this one, the program that is needed under this order, and then it was divided into 2 parts. And then this food has another category, etc., etc. Okay, and then this drinks also has another category, etc., etc. Okay, so this is what we're calling structured way of doing things. So as much as possible, you must come up with this kind of structure first before doing the things that you need to do. Okay. Well, I guess for some projects, especially if it's small, I guess it's not needed anymore. But if it's a medium to large project, this one is super helpful. You will realize that well, here you can uh, let's say estimate. I was able to finish 30% of the project. Okay. I was able to finish 60% of the project, and so on and so forth. So with that, you'll be able to know your progress. We'll be able to know, when will you be able to finish a project if you were, let's say, you've spent 1 month in creating this one, and then maybe another 1 month for this module, then probably another 1 month for this module. So you can estimate. So yeah, this will really be helpful if you have a structured diagram in creating your project. Anyway, so that's you know what we mean by structured. And then the design should be structured to degrade gently, even when aberrant data, events, or operating conditions are encountered. So for example, this one, uh, again, just like what I mentioned a while ago, Mom Teresa have used some deep words or hyperlinking word like the word aberrant. Okay, if I'm not mistaken, aberrant is like a part, okay, of data, or a small portion of data. Am I correct? Maybe. Okay. So it's my way of understanding the one is not correct. So it says here that aberrant is departing from an accepted standard. Okay, so it's like it's now way far from the standard that we have used to uh, use. Okay, so but still these ones may be still helpful. So something like that. Okay, so away from or departing from an accepted standard or diverging from the normal type. So in other words, this is normal and then it's just move right here a little bit. So maybe not that normal or not within the standard. Okay. So design should be structured to the grade agent. Well, this one's kind of similar with this one wherein I've explained the advantages of structured. Okay. And design is not coding at the same time, or vice versa. Coding is not design. Okay. So coding is just part of the design. Okay. So that is the best way to describe this one. Okay. And then design should be assessed for quality as it is being created, okay, not after the fact. I guess it's what is very straightforward. It's like quality over everything. Okay, so and then the next one is design should be reviewed to minimize conceptual semantic errors. Well, this is very obvious, of course, right after creating that specific module or just that part of your program, you have to review that one as early as possible. With that, you'll be able to minimize the errors that will come up in the future. Okay. Okay, so yeah, those are the principles. Again, this one is basic design principles. Okay, not software design principles, but it's the basic design principles because software design principle is different from this basic design principle, which we are going to discuss later on. But yeah, are we clear so far? Were you guys able to follow those basic design principles? Okay. So let's move on now to the next one. So we have this software design piece under SDLC, which is the very first step, wherein we have two level, okay, of this software design level. We have the external and then the internal design. So external focus on designing which modules are needed, their specification, relationship, and then interface among them. While internal design focus on planning and specifying the internal structure and processing the detail. Now, if you will, of course, if you will combine the student, that's the totality of the software design itself. Okay, it's just that we have these two parts right here. So yeah, I guess their description is already clear, so I will not explain this one a bit more. Let's now move on to the objectives of software design. So we have here the correctness, completeness, efficiency, flexibility, consistency, and the maintainability. Now, under this part, I think this one is very straightforward. I guess just by reading the, actually without reading the description, you already know what is the meaning of flexibility. You already know what is the meaning of efficiency. Okay, so I'll just skip this part and then I will leave this one to you guys. The next one is the software design principles. Now, again, this is the basic design principles, okay, which came from Davies and McGraw-Hill. And this is now the one that we're calling the software design, software design principles. We have four under this software design principle. We have the problem partitioning. Second is abstraction. Third is modularity. And then the last one is top-down and bottom-up strategy. So this one is also very straightforward. Well, I'll give you guys a brief description. So problem partitioning is, from the word partitioning, you're going to separate that one into smaller chunks or smaller problem. Okay, so let's say from one big problem into 5 smaller problems. Okay, of course, in doing that one, it will be easier to understand. Of course, it will become more simple, easier to test, easier to modify, easier to maintain, and then easier to expand. I guess you already know the advantage or the benefits of doing this one problem partitioning. In our daily lives, we are always applying this one. Okay, so if you're going to solve a certain problem, of course, we try to solve the small portion of it, and then little by little until until you were able to finish the entire problem. Okay, so I guess this one is very straightforward. So we have a note here as a number of partition increases. Of course, the cost of partition and complexity increases. Well, that is because it will uh, give you more time to uh, like, or you need to spend more time in compiling that one as a one project. Okay, so for example, you were able to create 5 modules wherein if you're going to combine those 5 is equal to this one project. Now that is not where the complexity is coming from, because the hard part in there is how will you combine these 2 module without a problem? How will you combine this 3 module without a problem? Okay, and then of course the cost of partition. I guess this is already a given, but yeah, that's why complexity increases as you have more partition. Okay. Moving on to the next one is abstraction. So this is just a way. Okay, so I guess it's better if we have a drawing. So let's see. Guess we can use this pizza ordering system. Wait a second. Okay, so this is already partition actually. Okay, so this is the first partition wherein you have to do the order part where the customer can order, where the customer can reserve. Let's say for food panda.